Okay, first off, I want to give everybody kudos. I really like the discussion boards and how you're responding to the discussion boards, responding to each other, and that. Just make sure they're substantive enough that it goes there, goes to what we're talking about, and just as go along. It's tougher to get stuff done in time in some weeks, and you just need to make sure that you're looking ahead and getting substantive responses in there. We're moving toward the midterm, which is next week. There will not be a Zoom next week. No Zoom. You don't need it. If you have any questions or concerns, you need stuff explained. Remember, everything comes from the notes. So if you have your notes organized, you should have absolutely no problem with the exam. It's a one-shot deal, and it opens on, I think, the 24th and closes on the 26th. Once it closes. So make sure that you're scheduling your time and getting it done and completing the task. Okay. If you have any questions or concerns about questions, make sure you write them down. We can discuss them if you are right. I'll give everybody the point. If you're wrong, I feel like I did something right for once and we're all good. But you do have the opportunity to question anything, but I will not answer any questions till after the exam has closed. So if you email me, I will hold on to it and I will answer that question after the exam is closed. Okay. Let's see. Next slide up is the midterm. Again, I just said that one attempt. All questions are generated from the notes. So let's get right in the meat and potatoes. I don't want to take all night. This is the point where I tell you we are really gearing ourselves toward week 8, 9, 10, 11, and so on and so forth. Some of the stuff you're going to be looking at tonight is stuff that you're going to be doing later, not the exact same data, because I just grabbed some data. But the idea here is if you follow the step-by-step process, watch the Zoom meeting, get the example in the book done early in the week. Remember, it is the example in the book. The only thing you don't use, okay, is how they write it up. You will have a specific write-up that you will do. You do that, you follow the directions, you're going to be just fine. Again, statistics is a repetitive art in the mode that we do now. I saw somebody put in there, I'm so glad, I'm glad we don't have to, I pray we never have to do the formula for standard deviation. No, you don't have to. Took that off the table. But now we're going to force you to think and draw conclusions. And the funny thing about a hypothesis is it really starts and stops and it's over. Okay? It really starts by you building it, you doing what you do, and you finish. When it's over, you make your conclusion based on that, but it really doesn't go anywhere from there. Remember I said at the very beginning, the statistics is really set up in the idea of there's no wrong answer. No true wrong answer, because everything is a level of probability. If you do it completely wrong or you have the wrong test, that's a totally different thing. But if you have all the elements correct, there's no really wrong way of messing it up other than if I don't understand 0.05 and above and below what that means and I picked the wrong way. Now those are mistakes. Those are not errors. You're not going to make a lot of errors. You'll make a lot of mistakes because you're going to want to do things on your own rather than following the directions. Sorry, real life, 15 years, okay? And those that do it exactly like you're told to do and don't add any fluff and don't add leader pages and don't bring in the SPS boxes and just give me what I'm asking for. No fluff, no titles, no nothing, just exactly what I'm asking for. Because if you were in my DNP class, I wouldn't even look at it. I would say you didn't follow directions because you're working on perfection. Perfection is not spelling your name right. I know some of you by the end of the week can't spell your name right. It's really hard. I'm the same way because you're so tired and you've been so busy. So don't do the extra stuff. I keep saying that. But I'll have probably 10 or 12 of you that'll have a leader page, and have titles and everything else. If this was your DNP, I would tell you, until you get it right, I'm not even going to look at it. Because when you're done with this, it gets put in your paper. It's a finished product. You're not going to take the header, and you're not going to take this. You're not going to take this. This is going to be a part of a section of the paper. On that paper should be the write-up and nothing else. I don't need to see the boxes. I wrote the class. I know what the answers are. If you do it right, I don't even have to go anywhere. It's when you start adding stuff, or you're adding words, you're doing crazy things, and then I got to look at my stuff and go, oh, yeah, I need to do this, and this, and this. If you wait till Sunday and it's not going to get edited and you're going to turn it in, all I'm going to do is give you the grade, send it back. In the comments, it will have exactly what was supposed to be there, and we go from there. But between the Zoom meeting, the directions, and how to do it, if you do it correctly, you can't miss, because you're doing the one in the book. I think in all of them, you're doing the one in the book, so you can know that you're going to have the right answers, because it should look exactly the same. And then you do the write-up. You get the first write-up checked in within 24 hours or less, and bam, we come back and you do the second one the same exact way. There's no change. You won't touch any other buttons than you did the first time. The write-up will look the same. Some of the words and the numbers are going to change, and then you have to draw a conclusion, and then you have to do the write-up that's in there. The write-up that's in there is set into sections, and I'll go over that another day. And you just fill out the sections. One say write-up, a result, which is your write-up, your full write-up. You'll do a research question, you'll do a purpose statement, you'll do a hypotheses for each of them. Then you, at the end, you'll do. I think there's another section at the end where you give like a little outcome or something. I can't remember exactly what it is right off the top of my head. That's a couple weeks away. But all these things that we're doing right now lead up to that, which should make your life a little easier, and you should understand a little more the more that you do it. And that's the real reason. So I'm off the soapbox and I'm getting into hypothesis. Again, some of this stuff is stuff that we have been doing for a long time. Okay? We've talked about it before. So again, and now I'm going to start to get fancy here and right on the screen. But again, remember the null hypotheses. Help me. Remember the word no here. Now, there is the word effect, but in this class, you will not use the word effect. But in your DNP, you may be looking at the effect of something along with a program, how a program is running. That would be an effect, okay? But some of the tests that you will run will look at either a difference or relationship. So you may have multiple, in your DNP, you may have multiple hypotheses, null and alternatives that you're going to answer, not just one. You're doing a straight qualitative, you're just going to have a research question. You're not going to have a hypothesis. You can, there's articles out there that say you can just use the alternative, but why waste your time when you're not really looking at that? But you have to understand the no and which one you're doing, difference, relationship, or effect. If there's another word, somebody, when you get in class, throw it out to me, but those are the ones that I know that are really being used. You're using observations, you're using any type of qualitative portion of it, and that you would be looking not so much in experience, but you would be looking at the observation in terms of the effect. So I do a lot of education ones, and it's all action research. So the bottom line is they write theirs, and the idea, will there be effect on reading an 8-week reading program? And then they'll do observations during that time, and they'll do assessment. And they use those numbers as their statistics, as predetermined numbers. And some of you will be doing that, okay? But you might not be doing the observations. You'd be looking at the outcomes of something. So then that would still be difference, or it could be relationship. Again, moving on to the next slide, which is the opposite. In this case, there is a difference. There is a difference. Okay? So there are 5 main steps to hypothesis testing. Now, the 2 of them can be switched. So state your research hypotheses, HO and H1. I didn't take out the HA because your professor might like the HA. It's fine. There's no difference between the two. Do exactly what your professor's telling your DNP professor's telling you to put in. Okay. Collect data in a way designed to test the hypotheses. At the same time, perform the appropriate statistical test. Well, I put in 6, and the first one is pick the right test. And pick the right test. So you're examining what data you're going to run, and you already know which tests you're going to run to be able to do this. So it's not like you're going to write it and then all of a sudden run a correlation. No, you're going to write it in the idea you already know that you're running a correlation, and you look into the relationship with 2 variables, independent variables. Okay. Decide whether you reject or fail to reject the null hypothesis. It's that simple. Those are the words you're going to come back to in a little while. Present your findings and results in your discussion section, and that's what you're going to do. Okay? You are looking to answer the research question. You're also looking, if you don't have, if your professor doesn't make you do a research question and you're only doing the hypothesis, you're just answering the hypothesis or you're answering both. It's that simple. Okay? But if you could make this, like I did, very, very difficult or very, very easy. It is build the right hypotheses, run your test. When you get to a certain point, you're going to do what I'm going to teach you both ways of doing it tonight. And I'm going to tell you how I teach my people to do it, because it's both of them are easy. It's the idea that some things in the rest of this class, it's not important to understand exactly perfectly everything it does. And I saw that in some of you. Some of you are looking for understand everything. You need to understand what you need to understand to get your degree. Sorry, it's the real world. No different than you do things at work that maybe somebody else doesn't do because it helps you in your job. It's the same idea. You can understand how everything goes, but you can't do it. I need you to do it. This is a just do it situation. Do it, follow it, get it right. It all makes sense in the end, hopefully, not as you're doing it. Because remember, we talked about slivers. You're going to get slivers of data. You're going to get 2 slivers of data, and they might be, and some of them are totally different ballparks. Okay? Just think of it as this way. This is like one section of an answer. There'll be another section of an answer, and another section. My master's thesis had 200 pages of data that I had to go through to pick out 10 or 12 different statistical things that made sense compared to what I was really what I was doing. All the questions worked, but some of the answers were vague. It didn't come out completely like it should, and there were some that were just glaring that pointed to things that I was seeing as I was doing all of the data. Okay, next slide. Okay, so I'm going to kind of lead into this. This is like a beginning place. So we're looking at here, we're looking at the bell curve. Okay, it's a normal distribution. Okay, in this case right here, we're going to start by talking about the critical value. Okay, when we move to the second half of this, we don't even worry about this. It's just what the answer is and which way it goes. I'm going to stay there because I'm going to give you some vague things. But understanding that if this critical value, this is the negative side and this is the positive side. And this will be the positive side of your answer that is in the data. Everything you're going to do from week 8 on is right in front of you. If you understand the words that we've been talking about, such as mean, standard deviation, we're going to start talking about t-value. We're going to start talking about p-value and p-value / the word significant, which is usually SIG period. If you understand where those are and you put them in there, it'll start to make sense. If you try to make sense of the whole thing all at once, it doesn't work. I can look at, you hand me a one sample t-test now, I'll be able to look at the words you put on a page. If you were doing your own and say, that's it. Well, what does it say? What does it say to you? There's that what word. Who, what, why, where, and when. What is it saying to you? What is it saying about the participants? And then think as simple as you possibly can when you think of your answers, and you're going to be just fine. You're gonna say, "Oh, statistics wasn't that hard." And somebody says, "Well, what is a one sample t-take?" So it tests one variable versus a test value. Well, what would your test value be here? I think 49. Can't be wrong. Okay, unless you're doing a survey and then there's a certain number you have to fit. But I'll get to that. So if that critical value ends up in here or here, we reject. Okay, straight reject, which means we would take the null. If we fail to reject, guess what? We're taking the alternative. This is where it ends. There's no more explanation to it. This is where I tell you that word scholar comes into effect. Sorry, scholar, C-H-O. Learn how to write with this thing, I'll be good. Scholar. Okay, that's really horrible, but that's okay. You're a scholar, and when you start to read, when you understand and you start reading at a scholarly level in this arena, you'll understand that you're not going to, what you see, you'll go, oh, I understand. It's this, and be done. It's like I say, it rained today. Really, do I have to explain it? There's no color commentary. Is it poured down rain? I didn't see it poured down rain. It poured down buckets. It flooded the front yard. Yada yada yada. No, it rained today. That is the conclusion of today. It is not raining now. Thank you, Jesus. Because I got to work. My first part of my job tonight is outside. So I'm praying that it doesn't rain the rest of the night. Okay? So get a visual of that, but don't try to fight yourself to understand it. The key word here is the critical value. So there are two actual ways of understanding whether you're going to reject the null or you're going to reject the null and accept the alternative. Okay. That's the way I always say it. The way the book has it, the way a lot of people is the way I'm going to show you tonight. When you go to your DNP, depending on which professor you have, they may have you worded a different way. It'll be in the same ballpark, but they may have what I say. They may have what the book says. They may have what they want. Now, just do it. You'll be good. Okay? So this is the kind of data that you'll be running. You'll be getting this. Of course, you're doing SPSS. If you're doing Excel, you got to do a whole bunch of steps to get to this that you just punch in. So those of you that still haven't tried SPSS, you might want to work on it a little bit prior to going. You probably want to move over. But if you don't, hey, I'm with you. I can do both. So when you look at this, I'm just going to run through this really quick. I'm not going to spend a ton of time. When this comes out, this is your variable that we're looking at. And this one is a water polo team. And I think we've already talked about this kind of thing before. We did a survey on whether the water polo team believed that they succeeded in competition. Overall in water polo. I think it was overall in water polo. Then you have your gender, which is male and female. So you're running an independent sample t-test. You need two variables. Okay? So this right here is the number of participants. You've heard this word 1,000 times now. We're going to start to use it, which is the mean. Here's your standard deviation. We really don't do any much with this. And then I'm going to run through this real quick. I don't expect you to know it because you're not doing it this week, but it will come up later. When we look at this, we have equal variances assumed and we have equal variances not assumed. I'm not going to define it. What we do is we look at the homogeneous variance test. If this number is above 0.05, we take the top line here. Equal variances assumed. So we work right on this line right here. So let me see, can I erase the board quickly? Whoa, what is going on here? I guess I can't read that on there. Oh, there we go. So I'm going to erase this real quick. So basically, we're working with that equal variance is assumed line, okay? And stay with that. So once we've chosen that equal variance, this is done. This is done. We don't even worry about that anymore. Okay? So we're not doing anything with the standard error mean here. Oops. So we're not really doing anything with this. It won't be in our paper. We won't worry about it. Down here, we are only dealing with the two-sided significance. And then this one right here, we don't even look at. We're done with that. Okay? There's more stuff that's on the page. I gave you what was important. Everything goes to the 100th place. So if we take that standard deviation right there from it would be 3.44. We take out the 1. Okay? We take out the 1. So everything goes except for what is it? Correlation. Okay? So in the idea that we are looking at this right here, we go down here and we go to, actually we go right to here and we look, for this one we go to the 0.22. Okay? And then we go over here to degrees of freedom. And at this point, I'm not going over degrees of freedom. It's going to go too long this for when we come to, well, actually the first week, or first and second week we'll go through. So just remember those numbers. That's the big key in those numbers. Okay? Cursor to do what I ask it to do. Where is it? So understand that we are looking at critical value. And we're looking at whether it's above or below the critical value. Okay? Somebody had written, a company written, if the p-value is low, the null has to go. It's the same idea. Okay? It's the same idea here. So let me see. I'm gonna make it a little bigger. Now you guys can see that the significance test on the screen, correct?
Yes.
Fantastic. Thank you. Okay, so and they're nice enough, but we deal with 0.05. Okay, so you have 0.05 and you have that DF. Okay. No, I think I just messed up. Got ahead of myself. Let me go back. I lied. We're looking at this number right here. I'm sorry, it's this number. So we're looking at negative 2.434. So sorry, man. Thank you. So we look at the 0.05, which is actually the alpha level or the p-value. Okay. And then we slide down till we get to the number 28 in this line, which is the degrees of freedom. So I'm going to go and great, we'll highlight. So if I go here and I go to 28 and I slide all the way across to that green mark. So what is that number? That number is 2.048. Okay. If I go back to here and I look at this number, 2.048. Whoa. So if it's 2.048, is that above or below that number? Well, we're about the negative sign.
Above.
Above. So do we Whoa. Do we reject the null or do we fail to reject the null? Give me a guess.
Fail to reject the null.
Exactly. So basically we have taken what? The alternative. Okay. We don't say we accept the null or we accept the alternative. We reject the null or we fail to reject the null. Okay. Okay. There is another way of saying reject the null and accept the alternative. I like that one the best because it's so simple to remember. But that's the things that we need to, that's the thing we're going to stay with what kind of like the book says, and we go from there. So bottom line is, in terms of this, it's over. It's over. It's done. It's done. It's done. It's done. Once you've got that answer, that's all that matters. So when you're writing it up and at the very last sentence, you say, due to the fact that the t value of negative 2.43 is above the critical value, we fail to reject the null hypothesis. And that's it. It is known exactly what happened. Because if I was a scholar and I didn't believe that, I would go back to critical value. I do the same thing. Oh yeah, we do that. It's just the way it is. So we can fight it or we can just follow through with it. Okay.
What's the t value? I'm sorry.
All right. I don't want you to go too deep into that. See
Okay.
that negative 2.443 right here? There's a little t above it.
How did we determine that the critical value was 2.048?
Right here in, hold on, I got to go back to that. You see, see the green line right here?
Yeah.
That green line is pointed to 0.05. That's your significance. That's your alpha level. 0.05, which we're going to talk about in a minute. Okay. So like I said, it's a little disjointed because I don't want to give you the first part and then give you the second part because sometimes it doesn't make sense either way. They're separate, but they do the same exact thing. Just so you understand that. We had that, and then we went to 28, and it was 2.048.
Why did we go to 28?
The DF right here.
Oh, there we go. There it is.
Everything is right in front of you. Everything's got a box with a name over it. So you're just good. I don't want you to get too hung up in that because we're going to come back to it deeper when we really start doing it. So this number right here, which is the DF. Okay. So let me clear this out. We're looking at this T value right here. T value, and we're looking at the DF. And then we went back over to here and we ran 0.05, which is not on the form. It's automatic. Everything is point for us is 0.05. It could be 0.05. It could be 0.01. It could be 0.0001. We stay with 0.05. Okay. They all go to, the lower you go, the less of a chance of a type 1 error. I will be here for 2 hours. Okay. I'll be here for 2 hours. 0.05 is a safe place to go. That's where we go. That's really the industry standard. And then it can move from there based on how you do that. But you're generally going to probably stay with 0.05 in your DMP. That's where we're going. That's what I was told. I'm good with that. Okay. So we took that fine. We slid down here when we got to 28. We came across to here and then we hit point there. We went back. We looked at this number right here. It's above it. We know that we're taking the alternative. If that was below it, we take the null. That's it. It ends right there. So that's the one way of doing it. That's the one where you have to really think. Now, let's see, where am I at? So what what do you fill in the blank here with for the null hypothesis? I don't know why I couldn't get it to go lowercase there or subscript. So the HO is there will be what?
No difference.
Thank you. And the H1 would be
There will be difference. A difference.
perfect. I know. I'm going over it again. It's regurgitation. I know. And so you know, why is he going over that again? Because I'll get papers that are totally wrong. And I don't like totally wrong. So this is kind of like what it looks like if I was to do it this way. I took it to 28 over here. You come back to this number right here. We've already got that number on the left-hand side, and we know that it goes there, okay? We already did this one. I don't know why this went all wonky, okay? Now let's talk a little bit about the p-value, okay? P-value is that alpha number. And again, this one for us is 0.05, okay? 0.05. Okay, the notes kind of go exactly what it does. I got something right here. It's the probability of obtaining results least extreme is the observed results of the statistical hypothesis test, assuming the null hypothesis is true. Okay, in other words, it quantifies how likely we are to observe the data or something more extreme purely by random chance the null hypotheses hold. That's a lot of jargon. Okay, a lot of jargon to either pick the null or pick the alternative. And I got browbeat on this one because I wanted to figure it out because it didn't make sense to me. And there'll be people it doesn't make sense. Focus on what I'm going to teach you right now. You'll have absolutely no problem because I'm going to tell you why at the very end. I'm going to hold on to that as like I got it in my back pocket. Okay. Some things you report. Some things you draw conclusions from. You can't draw a conclusion from the null and alternative. The only thing you know, it doesn't happen by chance. And 95% confident that it's going to happen. That's it. Okay. Now, if I move on to my next slide, the p-value is for this class in your DMP. I don't know why I took that out. For your DMP, we are focused on the following. It's two things. It's above 0.05, below 0.05. And this is where I tell you that when you do your DMP and you're doing this class, you've got to slow down when you get here to make sure that you're looking at the number correctly. Because you're going to look at a number sometimes, oh, that's below and it's really above. So just slow down a little bit when it comes to that. And you really look at 0.05. If it's 0.051, it's above. If it's below, other than that, it's below. 000 is below. I don't know how many times in 15 years it's 000, and they tell me it's non-significant. It's like, how? It's nothing. It's perfect. It goes. Let's see where I'm at. Oh, that's horrible looking. I'm so sorry, guys. That looks so good on mine when I did it. Give me 1 second to fix this so it looks a little bit better. That's better. All right. Move this up. Okay, now that looks a little bit better. Okay, so this is the most important part. So if I go back up to this right here, let me erase it right here. We're done with the top for right now. We'll come back to it in a little while. We're down here, and we are looking at this number right here. Okay, this number and this number do the same thing. If I'm using the critical value table, I'm using the T. If I'm using this method, I'm using the two-sided P. Sometimes it'll be written SIG, period. Okay? Done. That number right there, 0.22. Okay? Let's see if I can find this. Right here. So if I have 0.22, or was it 0.22?
I think it's supposed to be 0.0.
Yeah. Yeah, 0.022.
Okay, draw a little zero there. That works. 0.022. Okay, which one is it? Significant or non?
Significant.
Thank you. Thank you. All you have to do is say, is it below point, and just take out this one right here, get rid of this one. 0.02 is less than 0.05. Okay. If this number was 0.950, all right, significant or not?
Not.
None.
Non-significant. And some of you are going, wow, that's kind of, it sounds really simple. Yes, it's that simple. Where you did all that stuff where you had to find the DF and you had to get there. That's it. It's either significant or not. Okay. If it's non-significant, if it's significant, which one are we picking? Null or alternative?
Alternative.
Why are you saying alternative?
For significant?
Yeah, you just changed the significant, didn't you? Think of it this way. If the, if the p-value is low, then no must go. Did I say that wrong? You are actually right. It is the alternative. I don't know what I'm doing tonight. The null is if the null is low, if the p-value is low, the null must go. So we take the alternative. If it's high, we take the opposite. Okay. Okay. Pretty much that's it. So let me give you kind of a synopsis. I knew tonight wasn't going to take very long, but I'm sure you have some questions, so I will stay and answer all the questions that are there. Let me go back to here. I should have a whiteboard. New whiteboard. Okay. So the one we use is 0.05. And we get it from, it's called the two-tailed P, right? And that P is written P, and when you report it, it's P and whatever that number was, 0.022. It used to be you had to do greater than 0.05 or less than. Now it's a straight number. So that's the bottom line. That's exactly how it works. Okay. You look at that number. Is it above or below? You take the null or you take the alternative. That's it. And then you write it up. And then bottom line is you do the same thing. You say that the p-value was equal to 0.022. So we reject the null. We accept the alternative, or we fail to do the null. Okay, and that's it. One of those things you just got to do, and you're going to do it. You're going to do it once a week, twice a week, for the entire thing. So by the time you're done, you'll be able to whip those out in no time at all. When it comes time to do your DNP, you'll know how to do the hypotheses. And when everybody else is struggling with it, you're just going to go, okay, okay, I need one for this, I need one for this, I need one for this. I'm going to write it up, and it's the same every single time. And I didn't really say at the beginning, I don't expect you to know this today. I expect you to do your best to learn the words that I'm saying. If you want to do the critical value one, knock yourself out. It's in the back of the book. The table's in the back of the book. And you write it up that way. If you want to use the p-value, which is right in front of you. Now, in the newer versions of SPSS, it sometimes gives below 0.0, I think it's 0.001. 0.001. So if I have 0.001 and it says below that, I'm going to tell you we're going to use 0.00. That make our lives easy. That means it's between 0 and 1. It's good. It doesn't matter. It's significant either way. And we go and we lay it down and that's it. Okay. All right. So I'm done with that. Let me say this. How about if I stop the whiteboard? How do you stop the whiteboard? Welcome to whiteboard. Okay. Are there any questions? And if you have questions later on, email them to me. Give me a call. I'll be more than happy to go over whatever you need. Okay. And go over everything. But it's kind of like one of these things you just got to have it in your notes and be ready when it comes time for actually not the first 2 weeks. Like week 8 and 9 are descriptives. They're not really tests. You're basically just busting out data and you're telling all about your participants in different ways. After that, those 2 weeks, now we get into the one sample t-test where that's where I'm going to go over what a DF is and that. But for the rest of our class, we're looking at a relationship in our correlation week. And the rest of the time, we're looking at a difference. Is there a difference? How do we know there's a difference? The mean. That's the part I said I didn't go over. Sarah's going to tell you that. So again, this critical value here on this one is that. So if I go and slide over to the data again. So when you answer, you're answering the question of did it fail to reject the null or did you accept the alternative? I'm just going to call it that way. If I'm looking at it from that respect, that ends that. You've answered that hypothesis. Everything else will point and send it to the right place. You just report it. Unlike the limitation, just report it. Lay it on the table, let them read it, and make a decision on their own. Okay? We come back to this test, and we are looking at the difference in the means. Now, those difference in the mean is the male to female, which we kind of like did in our conclusions week. And now, once we've done the hypotheses and that section is done, the real test is whether the means are different. And the means are different, which then equates to the fact that we're picking the alternative because there is a difference. If they were both 21.8, it would be equal. Did that make anything else make kind of sense now? If those
Yes.
two mean numbers are the same, you don't. I mean, I don't have to look any further. It's going to be. I'm taking the null hypothesis because I'm taking the alternative. There is a there's no difference. It's a null. Oh my gosh, I'm just tonight. Okay. The means were the same. There's no difference. We're taking the null. There's a difference. We're taking the alternative. So you can do your own checks and balances. By the way, I would never give you data that was equal, so you don't have to worry about that one. Okay, so there are checks and balances, no different than when we get to correlation. You're going to have numbers, and then you're going to do the scatter plot again, and you're going to be able to visually see exactly the same as what the numbers say. Same thing here. You have the t-value, critical value. Great. It's above the number. You wouldn't know that right off the top of your head. You have to look it up. You have the p-value, which is significant. And then you have the two numbers there. The difference is if you got to a more advanced test, you couldn't do that. These are basic tests. So if those basic tests run that way, then you're good. In what you're going to be doing, it's going to be right in front of you. The only one would be like the ANOVA, where you're dealing with three sets of variables. Okay. So did that? That's why I wanted to come back to that at the end. So those two numbers are different. We know there's a difference. We're only improving it scholarly by using either the p-value or the t-value, and therefore using the critical value. Because that last statement kind of brought it all together. So I'm going to question because I got to get ready to go to work. So as I'm tearing down my whole little thingy here, feel free to pop in with any other questions, and we need to get out of here so I can see your faces or not your faces or know who's left. Let me pray you out. So those of you who don't have questions can go. We have a whopping 8 people tonight. Woo! I guess my notoriety is dropping. All right, Heavenly Father, thank you for the day. Thank you for all the people that showed up. Thank you for the questions. I know, Lord, that some of them are extremely confused, and that is okay. Let be okay with that, Lord, because you're going to show them the right way. We're going to show, and then I'm going to help you. I'm going to use you as my guide, God, Lord, and I'm going to show them the right way. And things hopefully will start to make a little bit of sense when we get into doing the day. This is all pre-work to get them ready for what's coming to their future. And if they get this and they understand it, when they go to the DMP, they're going to have a great time. When they're done, they're not going to be as stressed as everybody else in the room, because everybody else in the room is still doing the old. So, Lord, please bless them as they go through the day. Keep them healthy, keep them prosperous, and keep them free from sin. And all God's people said, amen. So, if you have any questions, feel free to stay. When the last person goes, we go. I may have to switch over to my phone. There's a lot of questions, but let's go.
Thanks, Dr. Jeff.
No problem.
Thank you.
I'll get this posted as soon as it's available, and I can move it over to my site.
I have a question.
Yep.
For the homework for this week, for the
Yep.
Alternative, do we want to say like it will influence or it will improve
What?
when
For
we're
what?
talking about creating the hypothesis for the homework this week?
What was the homework for that one? It was the discussion board, right? We don't improve anything.
Okay,
Our
so
job,
it'll
our job as
influence.
statistician, our status in terms of being, we're looking for a difference, an effect, or a relationship. Hold on, let me pull that up real quick. So you're talking about, which assignment are you talking about?
Let me pull it up.
The name of it. I've got it right here. Are you talking about the creating hypotheses one?
Yes.
Okay. You got 5 prompts. You're preparing a null and a hypothesis for each prompt. So take the first one. What's the null?
Okay, I'm sorry, I have to pull it up real quick. Sorry.
That's fine. I got to pack up in here. Pretty good. Pretty good. I could have just shared my screen. We should probably be faster.
Okay, I have it up.
Okay, it's on the screen.
Okay, yeah. So we're just going to say that it affects it. It doesn't, we're not going to say that it improves it or it
Tell me, no,
influences.
tell me what the actual null hypothesis is.
Let me pull it up.
The
quick.
HO equals what? There will be
A difference or not difference.
nope. What's some key word there? Impact. So is it effect or is it a difference or is it a relationship?
Pick one.
Okay, so I'm trying to remember which one I did. I think I did
I don't want to
the
know that. I want you to tell me. I want you to tell me right off the top of your head. I won't make the work. You ask the question. Now you got to work. Is it an effect? Does that look like it should be an effect, a relationship, or a difference? You have 2 seconds to answer, or I hang up.
for which one?
For the nursing education, the very first one on the screen.
Okay, what is the impact? I'm trying to read it. It's really small. What is the impact of?
Simulation based. You already should have the answer.
Okay, so it's an impact.
What do you think impact would be? Pick one. 5, 4, 3, 2, 1. Your
I don't
favorite.
know what you're. I don't know what you're
It's
asking.
either an effect, it's a relationship, or it's a difference.
So it would be an effect.
Perfect. You got it. Perfect. So what is the effect of what? There
The
will
effect of the
be,
training.
I'm sorry, my bad. There will be no effect of what?
Of the training.
No, of the impact of the simulation-based training on nursing students' readiness for the real world clinical situation. Okay, you could look at the whole thing. Actually, I got to change it back. It's a little different. There will be no difference in simulation-based training on nursing readiness for real world clinical situation compared to traditional classroom instruction. Everything's right in front of you. So I was wrong. All right. It would be a different. I didn't see the word compared. Okay, what would the second one be?
So how could regular hand hygiene?
Hold on, let me see if I can make it bigger.
Oh, thank you. Okay, so I lost that second one.
Here it goes.
Thank you. Okay, so how could regular hand hygiene audits and feedback influence the rate of hospital-acquired infection in a healthcare setting?
So what's the key word in that sentence? Starts with an I. I'll help you out.
Influence.
Perfect. So that one would probably be in effect. HO would be there will be no effect of regular hygiene hand audits and feedback in hospital acquired infections. You wanted to put the rest, it wouldn't matter.
Okay.
It would be, oh, what is it?
Okay, that's helpful. Thank you. And then this is gonna
So-
sound bad.
No,
But
that's fine.
okay, with the when you had that grid and it said non-significant and significant. Okay, so
Mhm.
when it's non-significant, we are accepting the null hypothesis,
Um,
or when it's significant. I'm just confused. I'm sorry.
above is there's a difference. We're taking the alternative, and below we're taking the null. You know, let me get back to you.
Okay, I'm sorry.
I'm a little brain dead for some reason. It's been a long day.
Okay, sorry about that. Well,
No, that's my bad. I should know that right off the top of my head, but right now it's kind of confusing. So I will uh, send you a note as soon as I get it. That makes sense?
okay, I appreciate that. Thank you.
No. Yeah, you won't need it right now, anyways, because you're not really doing that. All you're really worried about is remember, it's the same for all of them. It's
Okay.
written the same way for all of them. There is no blank. There is, and then the other one is there will be a blank. The blank is either effect, relationship, or different. That's it. Nothing.
Okay, that helps.
Your brain is overworking, just like mine did.
Probably.
You just have to just know that it's all written the same every single time. there is either an effect, relationship, or difference, and just gotta tell what you're looking at. So let me give you
Okay.
the example. How does the use of advanced wound dressings impact the healing time and rate of wound infections compared to traditional dressing? So there will be no effects on the use of advanced wound dressing to impact the healing time and rate of wound infections compared to traditional. There will be an effect, and you copy and paste the top one to the bottom, the rest of the top and the bottom, and it's done.
Okay, thank you.
No problem. Yeah, so I'll get back to you on that as soon as I can get logged in. So probably first thing in the morning, I'll put it on my list, and I will have that answer, and I'll put it. I'm sorry to put it in your outboard, but I kind of mumbled a little bit in that. That wasn't cool. So,
That's okay. I get it.
But,
I get
yeah.
it. You're on your way out. I appreciate
No
it.
problem.
Thank you very much for meeting
Have
with
a
us.
great night. Bye bye.
You too.